Thank you for inviting me to speak on increasing intermodal rail use based on a case study of the San Pedro Bay ports of Los Angeles and Long Beach using the Alameda corridor. I've worked on master planning and engineering the rail infrastructure for these ports for the past 30 years, and my current assignment is leading the Alameda corridor. I'd like to begin the presentation with a video giving you a background on the Alameda corridor.
Moving cargo quickly and efficiently is the key to a successful port. Here in Southern California, at the ports of Los Angeles and Long Beach, we're the largest international gateway for goods serving our communities and the entire United States is situated. That mission-critical goal is even more complex given the volumes of cargo. Currently, 1 in 5 international cargo containers in our nation comes through these two ports, where nearly half of the inbound cargo is transported by train to markets east of the Rocky Mountains. Getting this cargo from the docks to the transcontinental railroads east of downtown Los Angeles is the job of the Alameda corridor. The corridor was developed to consolidate 3 low-speed branch lines that previously traversed and impacted many communities into a single low-impact, high-speed, high-capacity rail line. The corridor eliminates over 200 street-level crossings that caused traffic congestion along the pre-corridor rail lines, increases the speed of trains from 15 to 40 miles per hour, and significantly reduces emissions from trucks, a key objective as both ports adopted their Clean Air Action Plan to reduce the environmental impacts of cargo operations. A single train serving the ports eliminates 750 truck trips from local surface streets and freeways. With 30 train movements per day, the corridor eliminates more than 15,000 trucks that would otherwise impact surrounding communities. The 20-mile rail expressway has 3 parallel tracks that can carry several 2 to 3 mile long trains simultaneously. When operating at full capacity, it can handle up to 150 double-stack trains each day. The Alameda corridor is an eco-friendly transport option that eliminates truck trips, improves freeway congestion, and reduces emissions and other contaminants to improve regional air and water quality. The corridor can be described as 3 segments. Starting at the ports of Los Angeles and Long Beach, the South Corridor stretches approximately 7 miles from the ports to the SR 91 freeway in Compton, where the Alameda corridor descends into the 10-mile-long Mid-Corridor Trench. The Mid-Corridor Trench is a key feature of the corridor. The trench is 10 miles long, 33 feet deep, and 50 feet wide, running adjacent to Alameda Street. With 3 parallel mainline tracks fully below grade in the trench, it passes beneath street traffic traveling through Los Angeles, Vernon, Huntington Park, Southgate, Linwood, and Compton, causing no interference to community traffic flows. This has allowed these communities to develop new and affordable housing with reduced noise, 2 new shopping malls that offer communities convenient shopping, 2 new high schools, public transportation with improved on-time performance, better traffic flow, and better emergency services response time. The trench is also out of sight, and construction was coordinated with each city to minimize impacts to adjacent businesses and incorporate aesthetic architectural features. The north end of the corridor begins where cargo trains emerge from the Mid-Corridor Trench at the Union Pacific J-Yard and continues eastward to the Transcontinental Rail Line through an area with complex coordination of industrial development, roadways, and commuter rail lines, and continues eastward towards the Transcontinental Rail Lines. With cargo volume continuing to grow at both ports to meet our nation's increasing demands, and with new technology making it possible to build longer and longer trains, improvements and enhancements to the Alameda corridor are constant. That is why, since the corridor opened on April 15, 2002, additional construction projects have been undertaken to further help the region efficiently handle cargo and relieve stress on the environment. The ports of Los Angeles and Long Beach serve as a vital economic engine to our region and the country, and they have proven to be progressive environmental stewards of our community and the earth. The Alameda Corridor Transportation Authority is integral to enabling the ports to move cargo efficiently, reliably, and with significantly reduced impact to the surrounding communities. The Alameda Corridor, connecting the ports to the nation.
Let's discuss two aspects of increasing intermodal rail. The first is by increasing demand, and equally important, ensuring that adequate capacity is provided to carry the demand. Other ports with rail connections are in competition with San Pedro Bay for discretionary intermodal volumes. Primary competitors are Pacific Northwest, Canada, and East Coast ports. Shippers started diversifying in 2015 after a labor disruption, but San Pedro Bay has outstanding benefits compared to other ports, including delivery times, which include sailing, port handling, and landside transport. Being big ship ready with deep water, modern wharves, and ship-to-shore cranes for the largest container ships. And San Pedro Bay has invested in massive terminal development and has a highly trained labor pool to work those terminals. Finally, San Pedro Bay is committed to green port policies that lead the industry, which will pay dividends as other ports play catch-up. For the cargo that comes to San Pedro Bay, there are three basic modes of landside transport. Direct intermodal, also known as IPI. This mode will transport international boxes directly from Southern California to Texas and Midwest destinations. Then there's local. These boxes are destined for our regional market. And transload intermodal. International boxes are taken to local warehouses where they are processed into 53-foot domestic containers or trailers. IPI is the primary focus of on-dock rail. Over 90% of IPI is handled on dock. Local cargo is almost entirely handled by truck, as is transload cargo. The pie chart shows the mix in 2006 of these three modes, and the histogram shows the dramatic growth of transload cargo in the ensuing years. Transload is driven by several factors, but keys the economics of moving cargo in a domestic container, which can handle 50% more than international container. Transload also has the benefit of capturing international containers locally and returning them to Asia more quickly. This downward trend in IPI reduces demand for on-dock, but also increases transport of cargo by truck through the region, which increases congestion and emissions. To increase intermodal rail, the concept of short-haul rail is being evaluated to move some of the transload containers from the port to warehouses by rail, bypassing the most congested highways. Now that we've discussed demand, let's discuss ensuring capacity. And we'll start with the main lines that bring cargo to the ports. Alameda Corridor has ample capacity, as presented in the video. To the east of Alameda Corridor, mainline routes from downtown LA to Cajon Pass are challenged by being shared with passenger rail lines. But I have confidence in the Class 1 railroads to ensure capacity needed for freight. The connection from Alameda Corridor to the ports is the biggest challenge to capacity. The ports have 12 terminals with on-dock rail. The port's development of these on-docks started in the 1980s. It was quite ambitious and quite controversial. The proof of the concept is shown today by nearly all IPI cargo being handled by the on-docks. However, this creates a significant challenge for rail operations, providing capacity to handle trains to and from each of these many terminals. To plan capacity to meet future rail demand, the ports have conducted periodic macroeconomic forecasts. Each cargo forecast has responded to the economic environment of its time. The 2006 forecast followed decades of dramatic double-digit annual percentage rate growth. The 2011 forecast followed the worldwide recession that occurred in 2007 to 2009. It is estimated a 10-year delay to reach the maximum port capacity of 40 million TEUs in the 2011 forecast. The most recent forecast by Mercator in 2016 showed that those cargo volumes may be delayed another 5 years. Forecasts have not been done since COVID-19, and the impacts are not fully known, but we're currently tracking well to the 2016 forecast. Significant planning goes into ensuring that the port has capacity. The port rail system is made up of components, including line haul, local rail network, and rail yards. Capacity planning is best accomplished with focus on individual components of the rail system. We start with the rail yards, then look at the local rail network, and finally main lines, which are primarily part of the Alameda corridor. Conceptual planning is performed by highly experienced rail designers and operators. Capacity modeling of rail yards is performed by kinematics-based model and discrete event simulation modeling. Capacity modeling of the local networks and main lines is performed using the Rail Traffic Controller Model, RTC. The modeling helps to identify deficiencies in the rail system where bottlenecks occur or capacity is constrained. Once those are identified, then we look to improvements to address those deficiencies. The results of the planning provide a rail enhancement program that delivers projects required to meet demand on a programmed schedule. The map on the left shows the projects that are required in 2025, which include significant improvements to the rail infrastructure. And the map on the right shows the requirements in 2045, with even more development of major terminals and on-dock facilities, as well as connections through the rail network. The results of the programmatic rail system planning are a set of projects that are categorized, prioritized, and programmed into a $3 billion rail enhancement program. The implementation schedule and resulting cost spread consider environmental clearances, permits, funding, property acquisition, engineering, and construction. One example of the rail program development is the Pier E on-dock rail yard, also known as Middle Harbor Terminal, operated by LBCT. This yard has been proceeding with phased construction during active operations and is now fully operational. It includes wide-span rail-mounted gantries over 8 tracks with 4 support tracks. Wheeled bomb cart transfer buffer is adjacent to the overhead gantry cranes, and it has a capacity of 2,000 lifts a day, or 650,000 lifts each year. Another example of a major project in the rail enhancement program is the Pier B on-dock support rail yard, which is currently under design with phased implementation planned to begin in 2025 and be fully constructed before 2040. The existing Pier B rail yard is shown in yellow in the photograph. The closure of 9th Street, shown in the insert photo, has removed a constraint to train building in this corridor, providing significant benefits. Another early phase of the project will add 10,000-foot staging track to the existing yard. Remember the magenta area in this photo as we go to the next slide, showing the full development of that area. Pier B is the largest of the rail projects, estimated at over $800 million. It will include 5 10,000-foot tracks that will chamber trains arriving and departing on Alameda corridor. The overall project has 25 miles of track, which will provide storage for rail cars in support of on-dock terminals. The facility will have 41 tracks for holding and combining train segments by destination. Those tracks will also provide space to maintain inventories of empty rail cars or bare tables. The project is expected to increase on-dock capacity by 1 million lifts, a 20% improvement. In conclusion, on the topic of increasing intermodal rail use, it cannot be done by building a single terminal, but requires significant planning and investment of a complex. It requires marine terminals that are big ship ready with deep water and modern wharves. It requires efficient intermodal yards, preferably on dock or near dock. It requires a well-planned rail network to handle the complex train movements to serve those intermodal yards. And it requires robust mainline routes to carry the cargo and do so with minimized impacts on the surrounding communities. From the chart, you can see that ACTA and the ports are continuing to increase their intermodal rail use. And despite discussions of congestion and a general attitude of breakdown at the ports of Long Beach and Los Angeles, you can see that they're on path to have a record year in 2021. I look forward to answering any questions you have and discussing increasing intermodal rail at the conclusion of this section. Thank you.